Welcome to Calculus.
Our stress tolerance level has risen so high that nothing phases us.
On this episode, Stevenson will demonstrate
Let's go ahead and look at another example. So here we have a table. We're told that the functions f and g are differentiable for all real numbers and that g is strictly increasing. So the table above gives values of the functions and their derivatives at selected x values. And they tell us that h is defined by h of x equals f of g of x minus 6. So it is a composite. So question 2 is saying, explain why there must be a value c for the open interval from 1 to 3, where c is in that open interval, such that h prime at this c value is negative 5. So you're going to sit here and look at this and go, oh man, I don't know what to do here. This is super confusing. So let's take a step back and think about this for a moment. Well, f and g are both differentiable, which means they're automatically continuous. But if h is defined as a function of f and g, that means f is also differentiable and thus continuous. Because if you have functions that are both differentiable and then you compose them, then the result of the composition means they are also differentiable and thus continuous. So, okay, where am I going with this? Well, they're asking you for some value such that the derivative equals something. This is an existence type of question, which means we have to use one of our 3 existence theorems. So an intermediate value theorem doesn't seem to work here because we're not asking for particular outputs. Extreme value theorem wouldn't apply here because we're not asking for an extreme value. So that leaves mean value theorem, because mean value theorem says that a particular c value, a derivative at some c value, will exist given certain conditions. So we're going to show that there has to be some value here by using the mean value theorem. So the first thing we want to do is remember what the mean value theorem is. Alright, so h of x is defined as follows. So in this particular case, what we want to show is that h prime of c equals negative 5. So if we can calculate this form here, we're going to apply this side of the mean value theorem. Okay, so what's my interval again? 1 to 3. So let's calculate h of 3 minus h of 1 over 3 minus 1. So what we just did here is we just did the average rate of change using the interval they provided us, and we've shown that we can get negative 5. So we've actually found the other side of this piece here, of this h prime of c equals negative 5. Now, why does this work though? Well, what did we say in the very beginning? We know h of x is differentiable, thus continuous, on that interval. So that means that's the component of the mean value theorem that is met, so thus this is true by the mean value theorem.